In 1995, a group of scientists decided to do something many called the biggest waste of time in the history of astronomy. They pointed the Hubble Space Telescope, the most expensive instrument humanity had ever built, at a patch of sky that was completely empty. No stars, no galaxies, just an absolute void, no bigger than a grain of sand held up against the night sky. Then they waited. 10 days. When the image came back, no one said anything for a few seconds. That empty patch, that absolute nothingness they had aimed the lens at, contained more than 3,000 galaxies. Each galaxy holding hundreds of billions of stars. Each star, in all likelihood, orbited by planets of its own. In a single grain of sand held up to the sky, 3,000 universes in miniature. And here is the thing that keeps me up at night. That was just one corner. What about the rest? We used to think our solar system was special. For most of human history, we looked at the night sky and assumed the planets circling our sun were a rare exception. A cosmic accident, a lucky fluke in an otherwise empty universe. We were wrong, spectacularly, beautifully wrong. Here is what we now know. There are more planets in our galaxy alone than there are grains of sand on every beach on Earth. And most stars, the overwhelming majority, have at least one planet circling them. So when you look up at the night sky and count a few thousand stars with your bare eyes, you are actually looking at thousands of solar systems stacked quietly behind the dark. But let's push this further. Let's really push it. What if those solar systems weren't just out there in the abstract distance of space? What if they were practically around us, packed so densely that we were essentially living inside a vast layered city of stars? What would that actually change? For science, for life, for everything. The first thing you have to understand is that space is not what movies make it look like. It isn't a flat black canvas dotted with a few lonely lights. It's a three-dimensional ocean, thick with stars at different depths, different distances, different ages. And even in what astronomers call our local neighborhood, within just a few hundred light-years of Earth, there are thousands of star systems we've already mapped, each one its own sun, each one potentially surrounded by its own family of worlds. Alpha Centauri, our closest neighbor, is 4.2 light-years away. That sounds far, but in galactic terms, it's the house next door. And it has planets. One of them, Proxima b, sits in the habitable zone, the region where liquid water could exist on a surface. We don't know if it does, but it could. Now imagine that density multiplied. Imagine a region of space where star systems were so tightly packed that the nearest stellar neighbor was less than a light-year away. This actually exists, not here, but in star clusters, dense regions where hundreds or thousands of stars form together from the same cloud of gas. Globular clusters, for instance, can pack 1,000,000 stars into a space barely 100 light-years across. Inside one of those, the night sky wouldn't show you a few thousand stars, it would blaze with millions, so bright, astronomers believe, that there would be no true darkness. No night. Just an eternal soft glow from 1,000 surrounding suns. What would it mean for a planet, or a civilization, to grow up inside that kind of environment? Think about how much our own night sky shaped human history. Ancient navigators used the stars to cross oceans. Farmers used them to track the seasons. Philosophers looked up and asked the deepest questions. The stars gave us a sense of our place in something vast and ancient. Now imagine living on a world where the sky is never dark, where instead of a few bright points, you see a slow river of suns stretching from horizon to horizon. Would that civilization have developed astronomy the same way? Would they even have needed to invent the telescope to discover other worlds? Some of those suns might have been close enough to resolve into disks with the naked eye. And here is where it gets even stranger. In a densely packed stellar neighborhood, the gravitational influence of nearby stars would be significant. Stars passing close enough, over millions of years, could gently disturb the outer edges of a solar system, nudging comets, shifting orbits, sending frozen debris raining inward toward inner planets. This is actually something that happens in our own solar system on long timescales. But in a denser environment, it would be far more frequent, far more dramatic. It's a double-edged sword. Some of those disturbed comets might deliver water and organic molecules to a young planet, seeding the ingredients for life. Others might deliver catastrophe. Life, it turns out, needs stability. And stability is hard to come by when your neighborhood is crowded. But here's the twist that scientists didn't see coming. When researchers modeled whether planets in dense star clusters could survive long-term, they found something surprising. Many could. Planets in tight orbits around their host star, the kind that could be warm and wet, are actually somewhat shielded from the gravitational chaos of passing stars. It's the outer planets, the gas giants and icy worlds at the edges that would be stripped away or scattered. The inner worlds might endure. And inner worlds, it turns out, are often where the interesting chemistry happens. So life might not just survive in a densely starred cosmos, it might even thrive there. Now let's go even further out on the edge of imagination. What would it mean for civilizations? For intelligence? For the possibility of contact? One of the great silences of our universe is the Fermi paradox, the baffling question of why, in a galaxy so full of stars and planets and billions of years of time, we haven't heard a single whisper from another intelligence. The universe seems almost deliberately quiet. But in a densely packed star cluster, the distances between civilizations, if they existed, would be dramatically smaller. A radio signal that takes 40,000 years to cross our galaxy might only take a few hundred years to span a star cluster. A journey that seems impossibly long with current technology becomes merely ambitious. In that kind of universe, civilizations would encounter each other, influence each other, perhaps cooperate, perhaps compete. The story of intelligent life wouldn't be one of lonely islands shouting into the void. It would be something closer to a conversation. But we don't live there. We live in the quiet suburbs. Our sun is an ordinary star in a relatively sparse part of a spiral arm where the nearest stars are years of light travel away in every direction. We grew up in the cosmic equivalent of a countryside farmhouse, looking up at a sky that is beautiful but sparse. And that isolation shaped everything about us, our sense of loneliness, our hunger to explore, our suspicion that we might be alone. But here's the thing, even from our quiet corner, the evidence is overwhelming. The universe is full of solar systems, not a few, not thousands. Billions upon billions. The Kepler Space Telescope alone, staring at a tiny patch of sky, found over 2,600 confirmed planets in just a few years. Extrapolate that across the full sky, across the full depth of the Milky Way, and the number becomes almost incomprehensible. We are not alone in the architecture of the universe. Everywhere we look, the universe builds solar systems. It's almost as if it can't help itself. So what would it feel like, truly feel like, to live in a cosmos where that reality was visible? Where every night, instead of abstract points of light, you could see solar systems the way we see mountains on the horizon. Near, detailed, real. Where the knowledge that other worlds existed wasn't a scientific conclusion, but simply something you could see with your own eyes. Go back to that Hubble image, 3,000 galaxies in a grain of sand. Now multiply it by every grain of sand on every beach on Earth. That is how many worlds exist right now while you are watching this. We don't know how many of those worlds have life. We don't know if any of those civilizations are listening. We don't know what they might look like, or think, or dream about when they look up at their own crowded skies. But we know this, the solar systems are there. Countless of them, surrounding us in every direction, at every depth, across the full expanse of everything. The sky you'll look up at tonight is not empty. It never was. It's been full all along, just waiting for us to finally open our eyes.